Okay, let's go ahead and continue our discussion here of energy flowing through an ecosystem. Again, I have this food web pulled up. We'll talk a little bit more about it now. If you'll notice at the bottom of this food web, and don't necessarily, think of it as the bottom. You can also think of it as the lowest trophic level, which we'll talk about in a bit. You have a bunch of trees, decomposers, things like this that are kind of working together. Decomposers are helping, of course, fix nitrogen, helping to break down some substances to allow them to be easier for these plants to take up. But essentially, sunlight, right? I'll draw a little sun out here again. Draw a lot of suns in my videos. Is shooting photons. This energy is being absorbed by this level. These autotrophs, right? We'll talk about autotrophs in a little bit. I'll define it. And then from this level, you have things that tend to eat this. These arrows indicate energy flow. Energy flow. Energy flow. Let me write it up to the side here. These arrows indicate energy flow, right? So this specific tree frog is getting energy from organisms at this level. Now, if you move up, energy is still flowing up because this raven eats the Pacific tree frog, right? Black-tipped jackrabbit also eats the Pacific tree frog, right? And this rabbit is in turn eaten by lions. You can tell in this scenario, and I think this is a good practice to get into, is to just think about what would happen if you remove an organism from this food web, right? If you remove this rabbit, which populations are going to increase? Maybe the Pacific tree frog population increases possibly because it is something that is eaten by the black-tipped rabbit. Maybe this bobcat has to eat other food sources, so the western whiptail decreases, or the pine marten decreases because he no longer has access to the black-tipped jackrabbit. So removing an organism can really complicate things in these food webs, right? Again, I'll say it again. I know I've said it a few times maybe in these videos, but the Amazon rainforest, currently, as of the making of this video, is being burned to the ground. So what you're doing is you're removing a lot of these primary, these producers right here, the first step in our food chain. You're removing a lot of that. When you do that, you're going to reduce populations at this next level and up to this next level. It's kind of why in the city, you don't see a lot of, these apex predator types, mountain lions, bobcats. You don't see a lot of those in the city because there just isn't enough energy to go around, right? Okay, so autotrophs. Autotrophs, one way to think of it is autotrophs, they make their own food. They make their own food, right? Their food typically comes from the sun, right? So I'll just put energy from sun for photosynthetic organisms. Energy from sun. And for chemosynthetic organisms, you won't hear too much about these, but in the hydrothermal vents down here, you can see I put a picture of some hydrothermal vents. You get this energy from inorganic chemicals. Chemicals such as CO2, dissolved CO2, and methane, CH4. These organisms can actually break down those bonds in CO2 and CH4 to generate energy for this ecosystem. Some of the only things that can kind of live independent from energy from the sun. Now, don't get too caught up on those because most organisms are over here. Most organisms get their energy from the sun, photosynthetic organisms. So this chemosynthetic organisms, as far as autotrophs go, are not as not as populous on this planet. So we're going to talk mainly about photosynthetic organisms. Consumers, heterotrophs, must acquire food from other organisms. We are heterotrophs, right? We can't make our own food with the energy from the sun, right? And absorbing gases from the air. Heterotrophs need to acquire their food. So you have different levels of consumers, and we'll talk about these next when we talk about the trophic pyramid. But you have different levels. Primary consumers. These are the ones that eat autotroph. eat autotrophs. The secondary consumers, these eat the primaries, eat these primary consumers. And you have tertiaries, these eat secondaries, and so on and so forth, which we'll see in this food web. We'll look at it in the next slide here. But you do need to know these main concepts: primary, secondary, tertiary consumers. Know what a heterotroph is. Know what an autotroph is. Know the difference between a photosynthetic organism and a chemosynthetic organism. Again, photosynthetic, they get their energy from photons in the sun. Chemosynthetic organisms get their energy from inorganic chemicals such as CO2 and CH4, to name a few. Okay, let's talk about energy flow in an ecosystem. So, something you may or may not remember from normal bio is, let's say we have our solar energy coming in right here, right? First of all, where are you going to find your autotrophs? If you want, pause the video and guess, and then I will write it down. These are okay. So hopefully you've not paused. Autotrophs are going to go on this bottom level. These are the organisms that can make their own food. Plants, photosynthetic organisms, things like that get the energy. I'm going to put a percentage over here. 100% of this energy. 100% of energy. We're going to assume that the 100% represents the energy that is absorbed by these autotrophs. Now, interesting thing to note is 90% of heat and 90% of energy is lost as heat between each trophic level. So, a primary consumer comes by and eats some autotrophs. It's only going to get 10%. And 90% of this energy is going to be lost as heat. Okay, so we can. I'm going to put primary consumers right here. Primary consumers. Okay. Then we move up to the next trophic level, as they say. Obviously, this between each trophic level, 90% is lost. So at this point, from our original energy, we really only have 1% left, right? 90% of the energy that we got from this previous level is lost, and we're left with only 1% of the original energy, right? Again, let's go to the top. 90% of the energy from this last trophic level here is lost. You're only left with 0.1% up here. Of course, this would be, let me label this here. This is your secondary consumers. Secondary consumers and your tertiary consumers. Apologies for the handwriting, it's not the best. So this is kind of a basic trophic pyramid here. I think it's interesting to note, again, thermodynamics, right? We don't have a perfectly efficient energy system. In fact, I would say it's fairly inefficient, right? A lot of our energy is lost as heat, and only some is maintained to the next level. Without this constant flow of energy, right, from the sun up through these trophic levels, right, and then lost. Some of it, most of it's lost as heat, right? This is energy flow coming in one side and being lost as heat out the other side of this pyramid. Whereas matter, remember, just remember this. I'm going to draw it off to the side. Matter is cycled. Just keep that in mind. Keep that in mind. Matter is recycled in our environment, right? But energy is not a cycle. That's why we call it energy flow. Okay, I think that's enough for this video. Thank you for listening, and we will pick it up next time on another video. Thank you.